everyone. I am making a couple of short video recordings going over the code, the R code specifically for the visualizations that are included in this week's tutorials, because we weren't able to get to that in our R review session, and I thought it might be a good resource for some of you who might be wondering a couple of things as you work through these tutorials. So I'm going to also be doing these in the context of the Palmer Penguins dataset, which is included in the Palmer Penguins package. So if you wanted to download it, you go to this Packages tab, you click on Install, and you type in Palmer Penguins, which is this one right here. I'm gonna go ahead and click cancel since I already have it. So we're gonna load in the Palmer Penguins dataset so that we have the Penguins dataset available to us. I'm also gonna load in the Tidyverse package because I'm gonna be using some of the functions that we're used to, which is the pipe operator, as well as the ggplot functions that we're interested in for making these plots. So I've loaded in this package, and notice that it gives you all of these packages. I am getting a lot of warnings about my version of R, which I'll update later today. So this recording is entirely about all of the plots that we have learned this week about how we can make visualizations for a single numerical variable. So we have essentially 4 different plots we can make. We can make a histogram, we can make a dot plot, we can make a box plot, and we can make a density plot. So the nice thing about, or something that many of us love about ggplot, is that as we switch between each of these different types of plots, really only one thing changes. We notice as we go through each of these lines of R code, we still have the same numerical variable across each of these. So every single one of these plots has the same first 2 lines of code. The only thing that changes here is the geom that we're using. So here we're using a histogram. For a dot plot, we're using a geom dot plot. For a box plot, we're using a geom box plot. And for a density plot, we're using a geom density. So the nice thing is each of these plots also goes with a fairly intuitive name. If you wanted to make a box plot, then you should know that you're going to be using a geom underscore box plot. So let's walk through each of these pieces. So notice here that I am specifically using the pipe operator, which is covered in the second tutorial about this idea of making this sort of pipeline that connects both our data and our data wrangling operations as well as with our plot. So what this is specifically doing is it's taking my penguins data set and inserting it into the first argument of my ggplot. So this is just exactly the same as if I were to put data equals penguins in the first argument of ggplot, and the next argument is the aesthetics. So this piece right here, this is equivalent to using my data set and piping it in here. So that is entirely up to you. Which of those options is your preference. The nice thing that we learn in the tutorials is if we wanted to filter our data set before we plotted them, we could add a filter statement here, and we could do some type of filtering. And once we're done with our filtering, we could then pipe that into the ggplot without having to save that data set somewhere else. But that is in one of the tutorials. So here, when I run this code, I notice that I get an error, or I get a warning message, which is that it chose 30 bins, and it suggests that I pick a better bin width for my histogram. It also tells me that it removed 2 rows containing non-finite values, which are the 2 rows that are missing values for the bill length. So ggplot by default removes all of the missing values from your data set when it plots them. So these are 2 messages that are very helpful for us to know. Your tutorial walks you through how you could choose a specific bin width with using the bin width argument. And we could say maybe we wanted to try a bin width of 5 and see what that looks like. So if we choose a bin width of 5, we notice that, well, my histogram went from being really jagged to pretty large blocks. So maybe this was a really large bin width to choose. So maybe what if I wanted to downsize to 1? And we can see that that's kind of like what we saw before. This is maybe a little bit closer to the original bin width that was chosen. So if I wanted it to look something maybe a little bit smoother, then I could choose a slightly larger bin width and play around with it there. So this is one of the arguments that's optional for histogram. You could also, instead of choosing bin width, you could instead choose the number of bins. So this would be a specific number of bins. So say something like 30 was the default, so this is what we got before. If you wanted to choose slightly more bins, then you're going to get something that looks pretty jagged like this. If you choose slightly fewer bins, say 20, then you're going to get something that's a little bit smoother like this. So this is all of the optional arguments to geom histogram that you can play around with. When we switch to a geom dot plot, what we're doing is we're taking essentially this histogram where we have these stacks of data points in our frequencies, because we notice that the count is on our y-axis, so that's the total number of observations that were in this range of data. And here we can see that there was about 10 observations in this data range, but we don't know exactly if it's exactly 10 or if it's slightly more, if it's 11 or 12. We don't have that sort of minute detail in these histograms, but we do get that detail in these dot plots. So if I were to make a dot plot instead, it looks like my histogram, exactly like my histogram, except for every single dot represents an observation. So here I can see that when I look at this range of data, if I look at around 39 or 40, I can count all of these dots right here, and that tells me exactly how many of those penguins had a bill length in that range of values. We notice that these dots are kind of flowing off of the page, and so this is where we could use that dot size argument, where if I could choose my dot size, maybe I want to start with 1 and see what that looks like. Well, it looks like about what it had before, so maybe I'll make them a little bit smaller. Maybe I'll make them 0.5 and see what that looks like. And now we can see that they are substantially decreased in size, so maybe that was a little bit too much. Something that's covered in the tutorial is that we don't really want to pay attention to this y-axis when we're making our dot plots. We could choose to change this axis, which we'll learn those tools later on in this course, but we essentially ignore that y-axis and instead just look at this x-axis as the range of values, and we can count the dots for our frequencies because this y-axis isn't really doing it for us. The next thing is we can move essentially from thinking about the distribution of each of these data points to thinking about what do aggregate summary measures of each of these data points look like. So a box plot, instead of plotting the raw data, it plots numerical summaries of our data. So when we look at our box plot, we see that there is a box, there is a line in the middle of the box, and there's 2 lines outside of our box. So these are our 5 number summaries. So we have our min, we have our max, we have our first quartile, our third quartile, and our median. So that is what symbolizes each of these different pieces of our box plot. So we don't actually see our raw data points in this box. We only see the summary measures of our data, where the middle is the median, the bottom of the box is the first quartile, the top of the box is the third quartile, and these whiskers extend from the minimum to the maximum, so long as neither of those observations are deemed to be outliers. And in the tutorial, we talk about how each of these sorts of outliers are determined based off of the 1.5 times IQR from our first and our third quartiles. And if they are decided to be outliers, they're plotted as individual points. So finally, if we think back to these histograms and these dot plots, we can kind of see this underlying structure to what these variables look like. It kind of almost looks like there's 2 modes where we have a bimodal distribution that looks roughly symmetric and maybe has a slightly long right tail. But this density plot, you can think of it as drawing a smoothed curve over these dot plots or this histogram. So we still have this same code, but what we're doing is we're drawing this smooth curve, and we do see that sort of bimodal distribution coming out. We don't get to see how many data points are underlying each of these, which is why the tutorial strongly encourages you to only use density plots if you have larger sample sizes, because it's not a very robust plot. If you have smaller sample sizes, you can see it having lots and lots of peaks, and it's very sensitive to those sample size differences. So this covers all of the single variable plots that you can use in ggplot, and next up we'll have the 2 variable plots.